Good evening, Titans. And tonight we're going to look at simplifying rational expressions. So the objective is to be able to simplify a rational expression. Here are two rational expressions that can be simplified. So we're going to go ahead and take a look at these and how we would do that. First of all, just a few things with vocabulary. Again, reviewing, a polynomial is the sum or difference of monomials. A rational expression, again, is a fraction that must have a polynomial in the numerator and the denominator. We must have a variable in the denominator for it to be a rational expression. The domain of a rational expression, the domain are simply the values that we can plug into the expression that would give us an actual number. Remember, we can't plug in a value for the variable that would make the denominator 0 because that would make it undefined. So the domain would be all the numbers at work except for the ones that make the denominator 0. And then a reduced form of a rational expression is in which there are no common factors in the numerator and the denominator. Sometimes when we're simplifying a rational expression, we'll be able just to divide out the common factors right away. But there are times where we're going to have to factor the numerator and the denominator first and then divide out common factors. So, in this first example, we don't have to do any factoring. All we have to do is divide out common factors. So we first want to identify the common factor. And in this case, the 5's are common factors. Factors because the numerator is 5 times x, and the denominator is 5 times the quantity x minus 7. So the numerator and denominator have a common factor, and the common factor is 5. We get to go ahead and divide out the common factors. And since 5 divided by 5 is equal to 1, now we're able to just write what's left. And what's left is there's an x left in the numerator and x minus 7 left in the denominator. And now the second part of this will be to talk about excluded values. And so in this case, x could not equal 7 because that's what would make that denominator 0. Now, there are times where we're going to have to factor before we can look to divide out common factors. So we look to see if the numerator can be factored, and then we factor the denominators. Then we identify and divide out our common factors, and then rewrite in simplified form. So here is an example we're going to take a look at. Step 1, if we look for common factors to both terms in the numerator. Well, in the numerator there's a common factor of 3 in both terms, and there's also a common factor of x. So the factored form of the numerator is 3x times the quantity x plus 3, and then we still have the denominator of 12x to the third. Now 12x to the third is a monomial. It can't be factored. We could expand it out if we wanted to, but we take the factor that's on the outside and we divide it out with any common factor that's in that monomial. So 3 divides in there once, 3 divides into 12 4 times. X would be divided out with one of these x's, so that would make this x squared. So then my final answer in simplified form is x plus 3 all over 4x squared. And again, nothing more can divide out because the numerator is a sum, and I can never divide out part of a sum. I also need to state my excluded value, so x cannot equal 0. So again, here they have it shown where they expanded that denominator of 12x to the third and then divided out the common factors. And still again we get that final answer. And again, we have to state the values that make the denominator 0. So we exclude x cannot equal 0 because that would make the denominator 0. Here are some problems for you to try. Now, I'm going to go ahead and work these anyway, but if you look at number 1, first of all, if I look at the numerator and the denominator, they're both just monomials. So this is something we did way back in Chapter 8. And we just divide out common factors. The 9 and 24 have a common factor of 3, so 9 divides by 3 3 times, and 24 divides by 3 8 times. This x in the denominator divides out with one of the x's in the numerator. The y's divide out, and this z in the numerator would divide out with one of the z's in the denominator. So my answer is 3x all over 8z. Now, we need to state our excluded values, though, from the original problem. So we'd have to state that x, y, and z all cannot equal 0. Because since they're being multiplied, if any of those values are 0, then it makes the denominator 0. Now in number 2, the way it's written, we can't do anything the way it's written. Even though it looks real tempting to want to maybe do something with those 3's, we cannot do that. You have to divide out common factors, and since those 3's are being added, we cannot divide those out. So, what we can do, though, is factor the denominator. And the denominator factors into a, and then factors of 3 that add up to 4, plus 3 and plus 1. Now, I recognize that a plus 3 and a plus 3 are identical common factors, because now the denominator is a product. We can divide out the a plus 3's. I'm left with 1 on top over a plus 1. And again, this is my final answer. I can't do anything more with it. Now, state my excluded values. Again, I have to state them from the original factored form, so -3 and -1. If we take a look at number 3, again, nothing can divide out the way it is. We can't just slice and dice. All right, so we have to factor the numerator, which would be 3 times x minus 5. Factor the denominator into x minus 5 times x minus 2. And sometimes you might just want to state your excluded values right now, which would be 5 and 2, before we look to divide out common factors. Now notice x minus 5 are common binomial factors, so we're going to divide those out. And my final answer is 3 over x minus 2, where x cannot equal 5 or 2. And then this last example, again, notice how it's going to involve lots of factoring. We factor the numerator, x minus 5 times x plus 3. We factor the denominator, x minus 4 times x plus 3. Again, you might want to state your excluded values right now of x cannot equal 4 or -3. And now we notice that x plus 3 and x plus 3 are common binomial factors, so I can divide those out. And my final answer is x minus 5 all over x minus 4. And there's your final answer. All right. Again, nothing more divides out. So there's your final answer. Now, remember, just reviewing restrictions on rational expressions. If we take a look at this, for what value of x makes the expression undefined, remember we only have to look at the denominator. We set the denominator equal to 0, and we solve. And again, since this was just linear, it wouldn't be necessarily important to factor the 4 out. We could have just set 4x minus 20 equal to 0, added the 20, 4x is equal to 20, divide by 4, and x is equal to 5. And that would have to be the excluded value. And again, just with the excluded values, again, if we look just for the excluded values, here, since that's a monomial, we just know that y and z both cannot equal 0 because, again, it's being multiplied and anything times 0 is 0. Here, we'd set just the denominator part equal to 0. We get 2x is equal then to 12, divide by 2, and x equals 6 would be an excluded value. And the denominator, here again, we only worry about the denominator, so we set that equal to 0. We factor it, it's c plus 4 times c minus 2 equals 0. Set each of those factors equal to 0, and we solve, and we get c cannot equal a -4 or 2. Again, just to review, of excluded values, which is a major part of rational expressions. We always have to define and exclude the values that would make the expression undefined. We'll talk more about this Friday in class. Be ready to be able to simplify rational expressions and state excluded values.
Made with Doodlecast Pro.